Okay, so hi guys. I hope you can hear me. We want to begin our second webinar this year for Elixir Kenya, and facilitating us today will be Wanjiku Macharia. She's going to be taking us through pattern matching and recursion. So, if you have any questions during the webinar, you can just skip them until the end of the webinar, just so we don't distract her thinking process. So, if there's anything else, you can also post it on the chat. Okay, without any further ado, Wanjiku, you're welcome.
Thank you, Getty, for the introduction. So I hope everyone can hear me. Please say yes.
Yes, we can.
Okay, thank you. Let me share my cam. Okay. Everyone can see my screen?
Yes.
Thank you. So I'll be taking us through pattern matching and recursion in Elixir and Erlang. Okay, first, my name is Wanjiku Macharia. I don't know if I said that before, but anyway. So I'll be taking us through pattern matching and recursion in Elixir and Erlang. So what is pattern matching? Pattern matching is used for assigning values to variables and for controlling the flow of a program. So in Erlang and Elixir, the equals operator is not used as an assignment operator like in many languages. So for instance, if you say X, let me minimize this window. So these will be the shell I'll be using to run Elixir commands. So for you to access the Elixir terminal, you need to type in, the Elixir shell, you need to type in IEX and then hit enter. And I'll create another one here for the Erlang shell. For you to access the Erlang shell, you key in ERL and then hit enter. So if I say X equals 4 in the Elixir shell, this is pattern matching, but not assigning the variable X to 4. The same case for the Erlang shell. But now in this case, in Erlang, you use variables that are in capital letters. A variable in Erlang should always be in capital form for it to work. So X equals 3. And do not make the mistake I've made, like leaving the full stop. So for any command you would want to run in the Erlang shell, for it to work, you need to end with a full stop. So if I do the same and say v equals 4 with a full stop, my command runs. But without a full stop, it means that the statement is not complete. Okay, so yes. So the other thing I'll be taking you through is recursion. Recursion is the tail call optimization that is used in Erlang and Elixir. So a tail function calls itself, or it can call another module in itself. So for most languages, the approach of using recursion is sometimes demands a lot of memory, and to be executed every time, you can call a function in a recursive manner, and this call will go through the memory stack to be executed later. So this also depends on the amount of pushes in the stack, and it might be heavier than choosing a non-recursive approach to execute it. Yeah. So the downside of recursions is that non-tail recursions have more declarative feel to it, whereas the tail recursions usually look more procedural. Okay, so I feel that for us to understand these differences, the pattern matching and recursion, we would need a couple of examples. Okay, so I'll break them down into the different data structures that we have in both languages: tuples, lists, maps, and binaries, and pattern matching in function arguments. So I'll take you through first the Elixir examples and then the Erlang examples. Okay, so for the tuples, for Elixir examples, we will go into the shell, the Elixir shell, which I said you can access by typing the word IEX and then hitting enter. Let me clear this. Okay, so one of the examples I'm giving here is the lists, the head tail pattern matching of lists. So as you can see in this example, I'm using the con operator, which is mainly used in lists. So if I type in head, tail, then I assign this to a list 1, 3, 4, 5. And hit enter. So now I've pattern matched the head to the first value inside the list on the right side, and tail pattern matches to the last 3, 4, 5, the last values of that list. So if I type in head, I'll get back 1, and if I type in tail, I'll get back the list that is remaining. So another thing to note about lists is that lists are recursive data structures, and they can even be used in nested forms. So the other example we can look at is...
Just a minute. Is it possible
Okay.
to make the font on your terminal a little bigger? I can't really.
Yes. Let's see, I think it's Control Command X. Yeah.
Yes.
Sorry. Ugh. So just in case anyone didn't see what I was doing, I hope that's better. So as I said, head gets attached to one and tail attaches to the rest of the list. Okay, so I mentioned that lists can be in nested forms. So I'm going to give a convoluted example with tuples after I've taken you through the tuples example. Okay, so the other thing we can do under lists, say for instance, you have a list that you need to sort out, and after you sort it, you would want to access the minimum value that is returned in that list. So you can pattern match your list to a value on the left that has the minimum value as the first one, and then maybe the rest of the list which you don't want to use as the other part. So for us to sort in Elixir, you can use enum.sort. So 4, 5, 2, 8, 1, and 5. These are random numbers I'm picking. Okay, so my list has been sorted. And so if maybe in my program that I'm making, I just want to deal with the minimum variable. So if I call it somewhere in my function and reference the mean in the list, it will give me back the sorted lists with the minimum value as the first one. Okay, and the rest of the list is attached. Okay, so I'll take you through tuples now. So for tuples, in Elixir, we can use these. This is what a tuple is in Elixir. So a tuple pattern matching, I'll give an example of the date. and time. We can pattern match it to the calendar. Sorry, dot local time module. Just let me confirm this. Yeah. Sorry, my spelling was wrong. So in this case, I've pattern matched date to the first tuple, which is 2019 9, date of today, which is 27th, and the time is pattern matched to the current time that we have, since I'm running the calendar module in Elixir. So if I would want to return these values, the same case, just type the variable that you've pattern matched it to, and then time will return the time. So further along, if I break this down in terms of year, month, and maybe I want to ignore the date, get the hour, and ignore the time, the minutes, and get the seconds. I can use that tuple and pattern match it to the calendar dot local time module. So now if I want to use the variable year somewhere in my code, I'll just be referencing to year inside that tuple. And if I want to use the hour, you can type in hour and it's going to return to you the hour at that specific time. Okay. So far we've covered lists, tuples, and the other example was maps. So for a map, this is the structure of an Elixir map. Username. This is whatever I've typed first, that's a key. And the value, I can have it that way because I want to pattern match this. And then say, for instance, age. And age, that's a map. I want to pattern match this to an input probably I'm getting from the user. I'll use Getty's name and age. This is not, I don't know the answer to this, but I'm guessing. Then hit enter. So now I've pattern matched. If I type username, I get Getty inside that variable. And if I've pattern matched with age, I've pattern matched the variable age to Getty's age. So I'll have the age as 24. So if I want to only pattern match, say, the age and not the name, I can have this map appear with only one key value on the left side, and on the right side, regardless of what a user gives, the details. So the user can say, give their username, their age, and I don't know, and maybe a hash or a password. Hash 1, 2, 3, 4. Yeah. And we are going to have pattern matched only one value from the input we get, which is the username. username, which is that. So if I do the same here and probably change this date to 25 and have my user as Wanjiku. If I say username, I will get now Wanjiku. And if I try to get the age, my age returns 24 because age was already pattern matched to this first map here, as you can all see. Okay. So essentially pattern matching gives the Erlang and Elixir immutability aspect. So you cannot have mutation in this case. Okay, so another example I'd want to illustrate under pattern matching with Elixir is the chain pattern matching. Yes. So chain pattern matching is, for instance, if I say A, B, A is equals to B, which is equals to 4 plus 5 or 4 plus 4 and hit enter, I'll get 8. So in my code or whatever I'll be working on, if I use A, it will reference to the result of B, which is B equals to 4 plus 4, which shows that when you do a chain pattern matching, A will be the value of B. So B is the same value because it's a chain pattern matching. Okay, I think I can also give functional examples in code for this. So I had written some pattern matching examples here to give us a better understanding of how you can implement pattern matching as you run your work. So for this to run, to test this, you can type ix-s mix. Okay, what's up here? Okay, all right. This is a different error in the recursion example. Apologies for that. Yep, so this is inside pattern matching pattern. The file name m.area, the name of the module. So typing that is like alias in it. So if I type in now area.object and I assign an atom circle with the value 4, hit enter, it gives me the result. So let me explain this. So we've defined a module area and broken down a couple of functions inside it. So a function object is taking in an atom rectangle and a variable a and b, and after taking in that result in a tuple, it's supposed to multiply the result. So if I come in here on the terminal, taking the second example, which takes the same similar aspect of taking in a tuple with an atom and a variable r, I have assigned the tuple to contain an atom circle and a variable r, which is 4 in this case. So I'm pattern matching the value 4 to r, and also circle should match with the tuple I give on the atom I give on the terminal. So once I run this, it calculates the area of a circle, which is r times 3.14. It doesn't have the trailing zeros because I did not add the 3.14712. Yeah, that other part. So the same thing will happen if I call area.object and assign this rectangle And rectangle takes in a rectangle tuple and a variable a and b. So we need to give it two other parameters. So we allocate 5,2 and hit enter. It does the calculation, which is a times b, which is 10. So this last function here is like a catch-all clause that catches any other phrase that we try and give in our function. So if I come in here, for instance, and say area dot object and assign an atom triangle and say triangle has this area of a triangle is half b times 8 4 3 5 yeah, hit enter. So I get an error returned which says error unknown shape triangle. So that way you can be able to even catch an error because this doesn't pattern match to any of the clauses of these branches that we have, the def clauses that we have here, but it can pattern match to this, which is the unknown variable. So I will cover pattern matching now with Erlang. Yes. Zoom in. Hope that's big enough. So Erlang examples, as I said, in your terminal, you'll need to type the ERL command and then hit enter. So in Erlang, when you pattern matching lists, it's just the same concept because Erlang is the mother of Elixir basically, but this is the same concept even in functional languages. So V equals to at least 3, 4, 5, 6. So this will be a bit different. I keep forgetting the 0. Okay, good. Look at the exception that it's given. No match of right-hand side value 3, 4, 5, 6 because we've already assigned V a variable 4. So you cannot come and assign V again another data type, like data structure or any other data to V. So V will forever be 4. So if I say V dot gives me back a 4. So C, let's use a variable C to assign to us a list 1, 4, 5, 6, 7. And we get back our list. So another thing you can do using still the con operator, we should say head, tail equals to V full stop, not V, I keep forgetting, C full stop. So if I type in head with a full stop, I get 1, and tail full stop, I get 4, 6, 7 as the part of the trailing tail. Okay, so that's how you pattern match the lists in Erlang, sorry. Yeah, so we go to tuples. Okay, so I'll take in a tuple A, comma B, and say it's equal to tuple with an atom name and another atom age. Oh, I keep forgetting the full stops. And you add a full stop. So if I type in A, it's going to it has been pattern matched to name. And if I type in B and full stop, it has been pattern matched to age. So if I try and assign A say I assign it password, that will throw an error because there's no match of the right hand side value. Since my A is already bound to the name variable, which is here, it's already bound to this name variable. Okay. Records. So in Erlang, we have something called a record, which is just like a tuple, but has an extra field of the first element, which is the name of the record. So I'll show you an example of that. Yeah, this should be it. Okay, let me close this. Sorry. Okay. So this is also the terminal that I had logged into, but can get out of it so we can do it all together. So here, an Erlang module is created in this format. You name the module and give the name of the file inside the module. Then for you to write a function in Erlang, you need to export it for it to run. So once, like this add player is a function, but for me to execute this function, I need to export it. And convert is also a function, and sum is a function that I have written in here. So a record, this is a tuple, as you can see, but it has an extra element, which is the name of this record. And I have two records here, a player record name and a game state record. So I wrote this function to basically populate the record game state. So if I type in Erlang, ERL, sorry, on the shell, on the terminal, I'll get into the shell. So for you to execute an Erlang file, you need to compile it. So C, this is how it's done. C record, record example into brackets and dot full stop. Oh, because we're in the wrong folder, that's why it says that. So just a second, I will get into the right folder. CD. Okay, so ARL to get me back to the shell, then C record example full stop. So you get an okay record example if your module has fully compiled. If it hasn't, it will throw some errors for you to resolve. So, and yeah, who doesn't like resolving errors? So for us to execute the function, we are going to type in the record, the name of the module, record example, and then the function that we've written, add player, which we call with the arguments that it's taking. So here it's taking board, player name, cards, energy, dices, and game round. So if these are the inputs it's taking, it means that whatever I'll give here on the terminal is supposed to pattern match to the values board, player name, cards, energy, dices, and game round. And then in the game state, this record game state will be created with the values I give on the terminal. So add player, board could be chess, player name, Wanjiku, cards, kings, energy, high dices for game round 3. Then close the bracket, then full stop, hit enter. So as you can see, The record is returned with the name, which record have I inserted, which is game set, and the variables that I have added in here. And as you can see, I have done a double insertion. So I'm inserting the player name, cards, and energy inside the player record. That's why we have this tuple inside here. That is a combined, this whole tuple is a combined, is made of two records, basically, the player record and the game state record. Records are even used in tables in Erlang. So like an amnesia table will be created using a record, and also to populate the data in the table, you have to give the attributes of that record. Okay. So I think I've given an example on records for pattern matching also. And the other example I can give on pattern matching with a function in Erlang is this function I've written here called convert. We are converting the Fahrenheit to Celsius. So if I take in a tuple with the name Fahrenheit and a value in temperature and calculate the Celsius, I'll return the Celsius of the Celsius calculation and take and do the math on the rest part, on the other part of the tuple. Okay, so if we run this, convert Fahrenheit, comma, temperature of 56 in Fahrenheit, and we want to convert into Celsius. Sorry, full stop. Oh, because I have not undefined shell command convert. Yes, because I've not called it using the file name. Do not forget to do that, like I had forgotten. So convert takes in Fahrenheit, the temperature, and what I'm converting it to. So that gives me cannot convert Fahrenheit to Celsius. Well, that clause has been answered by this. Reason being, let's see. This is my catch clause, which is X. Anything that's we ignore the value, and then okay. So if I try with the Celsius one, just a second. Module name, record example convert, takes in a Celsius value. It did not pattern match to the values I gave previously. 34. Then comma Fahrenheit. Brackets full stop. Oops. I don't know why it's not pattern matching to these values, but I'll look into that and get back to you guys. I've seen it. So this is how pattern matching shows you who is the boss. So this spelling of Celsius is different from the spelling that I'm using in here. So you see, pattern matching catches minor details for you. So it will always be directed to this clause. So if we use the same example but edit it to match the spelling up there, it should then now work, as you can see. So it's going to give us the Fahrenheit value of the Celsius conversion. And if we do the same for the Fahrenheit and use the right atom that is used in here, it's going to give us the Celsius value of the Fahrenheit value converted. Okay. Good. So the other thing we will cover is recursion. Yep. So recursion, I'll explain recursion with examples. I can start with the Erlang one since I'm on Erlang. So my recursion example is very straightforward and basic. So taking a sum of a list and have the lists like split into two, the head and the tail, and then you take the head and add it to the value of calling this function sum again. You call the function sum again with the rest of the tail. So I've broken it down here that it explains why we have this working, basically, the recursion bit. So when you say sum, for instance, sum, I can even do this down here again. So if I say sum a value whose list is 4, 5, 6, I have split it into two. What I'm telling this list is, on this other side, take the head of the list, which is 4, this one, head of the list, which will be 4, and then add the head of the list with what you call inside sum, with the sum of the same variable, sum of the tail. So, but then our new sum tail is what? Our new sum tail is sum into brackets. So we have our head which has been left here. So our tail will now be 5. Our tail broken down in this format again, in the head tail format, will be 5 and 6. Yeah, that way. So what will be the result of applying the same logic of recursion? Recursion is here. This will result to us getting, our head now will be 5, which is, then call the same function with the remaining tail, which is now 6. But then I want you to note that our head at the beginning was 4. So our next result of this, the result of sum t, will be 5 plus sum t, which is the tail here inside 6. So if it keeps looping and repeating, being recursive, basically, we'll have sum now of the tail, because now we are calling sum with tail, which our tail now is 6. 6 into brackets. Then we are supposed to now get the head here, which is 6, and then add it to the value of sum t. But then in this case, what is the value of our sum t? Since our whole list has become exhausted, the value of our sum t is an empty list And if you can see below here on line 25, I have indicated that in case we get an empty list while running this function, return a 0. So this returns to us a 0. So at the end of it all, our sum will be the head of this plus the result of sum t, which is 5, plus the result of sum t in on line 34, which is 6, then plus the result of sum in this, which is 0. So the addition to this will be 15. So if we run the same function inside the shell, record example and give it sum the list 4, 5, 6 and add a full stop, get 15. So to test that this is actually true, you can also change this value here. Say if it's an empty list, return 3. You'll find that this number we have here will be 18 now. So for this to work, we need to recompile our module, record example, and then record example sum with 4, 5, 6. This should be a list, full stop. So we get 18 because now our empty list should return a 3. Okay, so that's recursion in Erlang. The same concept is applied in Elixir. So here we have a module named sum, and it sums numbers. So if I give values here, head, tail, if it's a number, it's supposed to take the head and sum also the tail, like the same way we were breaking down the Erlang summation. So if we run this inside, let me open another terminal. IX recursion dot sum, then sum dot sum numbers, 3, 4. I'm just going to give it 2 numbers. Okay. Oh. Inside which file? Recursion.sum, just a second. Yeah. Sum.numbers. This is numbers. NUMB. You have to be careful with these things. Okay. Okay, can't see where the error is in this. Let me run it. But anyway, I hope you've understood the whole pattern. I can look into that and get back to you guys later. So, yes, so that's pattern matching, a recursion explained to you by me. I think I'm done. Thank you.
Thank you so much, Wanjiku. If anyone has a question or a comment, this is the time. Anyone or anything at all.
Hi Wanjiku.
Hi, Paul.
Thank you for the nice presentation. Especially, I like the way you covered like both Elixir and Erlang, showing
Thank you.
just maybe the differences and maybe the similarities.
Yeah.
So my question is, when I was looking at the records, they look similar to something like structs,
Uh-huh.
or I mean, does Erlang have the implementation of struct, or in Elixir, do you have these records?
No, I've not seen records in Elixir.
Uh-huh.
And I think records is what is used in Erlang, like in place of, as you're saying, structs or maps.
Okay.
Yeah. According to the few interaction I've had with uh, Erlang, records,
Mhm.
I've not found any maps on Erlang. I don't think Erlang has maps, but I stand to be corrected if they're there. So record is what I use in place of what I would use as a map in Elixir.
Okay, thank you for that.
Welcome. Any other question?
Okay, I don't think anyone else has a question. So
Okay.
thank you so much, Wanjiku Macharia, for the webinar. We'll
Okay.
communicate the next webinar, what it will be about, and who will be leading us. So for now, goodbye and have a good week.
All right.
Thank you.
Thank you guys for showing up.
All right,
Okay,
bye.
thank you too.
Oh, bye, guys. Cheers.
Cheers.